All right, sorry for the interruption. So this is, hi, I, sorry, students coming in. Uh, so this is what I got. So this is the window for one bar stats test. And so we compare those two window. And so it's a normality check is okay. So three conditions are okay. They said that's called, some of the textbooks said it's assumption here. So those assumptions you have to list it. Rough sketch the data. So you have to sketch the data of the box plot. So you have to write down two box plot. Okay. Perform the test in interval. This is not the interval test. So you go to the hypothesis test. So right here, no hypothesis out. We did it. Significant level. Didn't say that. Hold on. Sorry. Okay, significant level. I wonder if I'm sharing the whole screen. Let me see. So significant level. It's did it list it somewhere? It didn't list it. So let's assume that alpha level is 5%. Okay. So when we get the p-value, we have to get down. So the equation we have to get here. Where's the equation tool? Maybe I have to open that. Assumption. That was 10-2. And the formula we have to use from the textbook is easy. So we get the AP stats, the formula sheet, which is, where is it? So this one, those two, okay? So I will grab this one, formula sheets right here, and we get the information from here. All right, now, this is confidence in, so T statistics, okay? So let me write down, it's a T statistics is stats equal, now, let's see. So let me write down the equation. So this is equation is required too. So you write down this one on the denominator, and this one is a difference of the mean is going to be here. Okay. So stats is right here. Let me write down the equation. You get the 24.75 and 21.86. Okay. So I put the equal sign, fraction, 24 point, so 24.75 minus 21.86. Okay, so this is statistics, and the parameter is 0. So a new difference is 0. So I put 0. Okay, denominator is going to be square root sign here, and fraction plus fraction. The first fraction is you get the standard deviation of the sample standard deviation, which is 2.84. 2.84. And I take the square root off, so let's put the square here. And 16 students, I believe. Let me recount later. 16. All right. Astley is, if you can't, I can't read here. I think 3.82, 3.229. So 29 and square. And I didn't count how many. 1, 2, 3, 4, 5, 6, 7 students. So it's going to be 7 here. Okay. So let me write down here. So this is the equation. So take a good look about the equation. See, this is 1, 2, 3, 4, 5, 6, 7 students, and this 16 students. So this is comes at the end here. Okay, this is standard deviation here. Okay, so let's see, and then let's get the t statistics here. All right, so let's see. So I will clean up here. Okay, so numerator is the difference of the mean is 24. I'm sorry, 24.75 minus 21.86. This data, this number, we might need later. So that's the difference is 2.86. So I keep this one separate. Numerator is square root sign and parentheses, maybe double parentheses, 2.84 square divided by 16. That's the first number. And you have to add second bracket, 3.29 square divided by 7. Oh, where's this? Divide by 7. Close the bracket. I need two brackets. And go here, enter. So this is standard deviation, 1.43. Okay, 2.89 minus 0. This is different from our parameter. Divide by 1.43. Enter, 2.209. Okay, that's the t statistics. Okay, only one tail. So if you think about 2.20, let's enter this one. 2. Second bar. Let me enter. Let me go back. 2.20. Let me write down here. 2.20. 2.021. 2.021. Okay. It's estimate. So I will create the double tilde. Okay. Now 2.021, you enter here. Second bars, TCDF, 2.021, and the infinity degrees of freedom is less than the athlete is less than the regular students. So it's a 7 students minus 1, which is degree of freedom 6. Okay, paste 0.0448, which is tiny. It's less than, so it's going to be, the p-value is, so I write down p-value. P-value is less than alpha level. So if this is around 0.044, 0.044. Okay. So it's a reject to, it's a reject null hypothesis. Okay. There's a significant evidence that the average of regular students is higher than the average of athlete students. Okay, so that's how you conclude. Now you have. I will ask one more thing. To create the when you run the t statistics, you have to run the value p-value location. So 2.201 021. You can go to stats. I'm sorry, second bar, draw t-shape, 2 point, I forgot, 2.021, I guess, 021. Upper is infinity. Degrees of freedom 6, 7 minus 1, right? And draw. It's not showing. So let me clean up here. Off. Test. Right. Second. Draw. Two point zero two one. 1, 8, 99, 6. Draw. It doesn't show, huh? I don't know why. 0.04. I don't know why it doesn't show the density curve. But it's supposed to be tiny, tiny density curve. That's, I don't know why it doesn't show it here. Anyway, so also you can do two sample z-test. Let's see. Maybe that shows the calculation and density curve. So you can do right here, two sample t-test, t like Tom, okay? Number 4. mu1 is greater than mu2, right? So this data is going to be list 3, and I enter list 4. Frequency is 1. Calculation. Okay, I wonder if it's t interval is 2.02. A p-value is much less than what we expected, 0.03. Okay, degrees of freedom, the way they count is 10. So make sure it's slightly off from our data, but the conclusion is the same. So let me cut this one. Now, this time I'm going to draw a density curve. So we go here, same place, stats, tests, two sample t-test. Now, everything is same, and I go to draw. Okay, now just show the density curve and tiny, tiny bit. So this one I want to see. I don't know why I couldn't create in the regular way, but you have to show me this one. And now, the important thing is highlighted place is the p-value. However, what is the significant level? Since this is such a little percent, which is 4%, I forgot. P-value of your calculation here is 3.5%, right? So it must be, you have to create the dotted line of the significant level, for which is alpha level here is a 5%. Okay, that's the complete version. And I already conclude the sentence for conclusion for this. So that's the significant test for this example. Okay, so that's the end of the third video. Okay. Will come more videos and please watch those. Thank you.